Okay, so good afternoon and welcome to our webinar series, Navigating the Digitalized Industrial Landscape, presented by Phoenix Contact. My name is Gary Huey. I'm with Springfield Electric and I'm your host. Today's session, Communication is Key, Even in Your Plant Network, starts with a high-level explanation of the industrial Internet of Things and progresses into the essentials of devices communicating through your factory infrastructure and machines. In the next hour, we will discuss networking considerations, managed switches, wireless in your factory, and data in Power over Ethernet. Today's presenter is Dan Schaefer. Dan is the Senior Product Marketing Manager for Network and Security at Phoenix Contact. Dan has over 20 years of experience and is an expert in networking and security solutions, specializing in network design, security, and troubleshooting. Dan is passionate about this topic and will provide you with educational information about industrial networking. Please, Dan, take it away.
Hello, everybody. Thank you very much for sticking with us. Gary, I appreciate the kind words, and to everyone at Springfield Electric who is making this possible, this whole series of webinars, thank you very much. This is a very exciting topic. We are in the midst of some very exciting times, and hopefully my slides are advancing okay. So what I'd like to do today is, over the next hour, give or take, is do a little bit of an introduction of the industrial Internet of Things. It's a buzzy topic that a lot of people have heard about. I have a handful of slides just sort of setting the table, and then where my place in this IIoT landscape might be, talking a little bit about communication as an enabler, and then moving into the infrastructure that is within your plants. A little bit on products. I try not to get too product focused. More on some technology, some use cases, where you can use things, why you might want to use them, and so on and so forth. We'll talk about basic connectivity. We'll talk a little bit more about some advanced connectivity, moving into Power over Ethernet, wireless, single pair Ethernet. And those last couple topics are more on the emerging side. So this might be not an exhaustive discussion of something like single pair Ethernet, but it is part of the IIoT ecosystem. And I'm actually anxious to get your feedback. So this is not a free lunch. Your feedback on if you're starting to hear, investigate, dig into some of these emerging technologies now, or if they're on your roadmap. So we can do that via chat when the appropriate time comes. So with that, let's talk a little bit about the industrial Internet of Things. IIoT is all about the data. That's something that we've been preaching for a number of years now. The term industrial Internet of Things, or the term Internet of Things, has been around actually like 35 years now. It started at a Procter & Gamble plant, P&G in Ohio, where they were looking to get advanced metrics from their machines, or what at the time were at least advanced metrics from their machine. They realized that they had things on this device that they wanted to pull information from, and a clever engineer called it a network of things, which then kind of morphed into the Internet of Things, and now the industrial Internet of Things. A lot of the IoT space has been driven by just an enormous increase in computing power, not just on individual processors, which by Moore's law, they double in power every 18 months, give or take, but also the aggregate of that processing power. Instead of just relying on a single device to do your data crunching, you now have, this whole cloud computing architecture built around it, AWS, Azure, Google Cloud, so on and so forth, that can really massively crunch enormous pieces of data very quickly. The result of this is, in everyday society, we are becoming a sort of a society, a community of data points. So what that means is, on your body, in your home, there are all sorts of things that are now collecting information about you. I have my Apple Watch on, it's collecting health metrics. It's also collecting information about where I am, what I'm doing right now, if I'm walking, if I'm running. It's collecting information about the world around me. It's able to tell that I'm in a geolocation that's currently 62 degrees out and sunny. There are Nest thermostats. My TV is probably at this very moment listening to me. Everything we do is now becoming a data point. In fact, I don't have this slide, but there's approximately 9 to 10 devices that each of us own and use every day that are communicating to the internet, and that data is going somewhere. So just like society is becoming more and more data centric, so is the industry around it. So this slide's a little bit of an eye chart, but you can see sort of a cross section of what's happening in the world around us. If you look, there is maritime applications, there is forestry, outdoor applications. There are things that are allowing our cities and communities to become smarter. They're capturing data about our traffic patterns, about building automation, about tunnels, about lighting, about campus networks. So all of that information is moving just from the individual and springing outward to be the world around us. And today we're going to focus mostly on the factory floor piece of that, what's happening in the factory. I just want you to know if there are those of you who have applications that are more centered around water, wastewater, or oil and gas, or other types of infrastructure outside of a contained factory or a contained plant, chat us up and we can talk a little bit about how that might be different or how that might look for your particular applications. So one last or one or two last data points on this is just to kind of give you the scope of all of this data. And we're talking about all of the data being collected about us, around us, on our plant floors, from our machines. If you are lucky enough to still be able to travel in a plane, for example, there are terabytes of data being generated. Every flight, every cross-Atlantic flight generates 12 to 16 terabytes of data on those 4 engines. So it's just a crazy amount of information. I have a little graphic up here that talks about just how much that is. Right now in 2020, the estimate is that we will use 44 zettabytes of data. That's zettabytes is a trillion, billion, if I have that right. I think it's 20 total zeros at the end of it. That's how much data is being generated all around you. Yes, some of that is cute Facebook videos with cats playing piano. Some of that is live streaming the next season of Ozarks, but it's also information that's all around us, making our lives, making our world a better place. Yeah, there you go. 1 trillion gigabytes with the 20 zeros at the end of it. So if we hone in just a little bit more and move from society, move from the cities, and start to hone in a little bit more on the factory floor, on the plant network, what kind of applications is all of this data allowing us to utilize? Where is it all going? What is it all doing? How is it actually giving us an ROI on our investments? Because we're spending a lot of money to make all of these smart devices. What are we actually doing, or what are we actually gaining out of that transaction? So it's about 10 different simple explanations, or 10 simple cases of how things are being used. One is, of course, maximizing uptime, and you achieve that through a variety of ways, including predictive maintenance. Predictive maintenance is simply saying, oh, this machine has been running hot. I've been capturing thermal data from it for the last 6 months. Something's going on with this part, or this engine, this motor is drawing more current. I can watch that graph start to spike. Maybe I've got a bad bearing. Maybe there's additional friction. Instead of taking an outage, I'm actually going to, or instead of having an unplanned outage, I should say, I'm going to wait to third shift where we're not running the machine, and I'm going to change it then on my time instead of when the machine suddenly craps out a week from now in the middle of the busiest part of the day. A little side note on that is GE, one of my favorite companies, has an initiative by 2023 to have 0 unplanned downtimes in any of their factories across the world. That's when you think of how big GE is and all of the places that they are producing, to have not one single minute of unplanned downtime is a very ambitious exercise for sure. And then some other things, increasing effectiveness, which will increase your yield, lower your costs, things like that. Providing anomaly detection. Again, that sort of ties in with that predictive maintenance, where you start to realize when things are going wrong, when something's not the way it should be. It allows you to get ahead of a potential problem, whether that's a physical problem with the machine, or it's going to be a quality problem with whatever machine or whatever product that machine might be making. And then remote connectivity, which is a session for an upcoming week, I believe next week, and better integration into the enterprise. We're going to talk just a little bit about that in a couple of slides and how that makes a big difference. So quick little bit of activity for you all before we move to the next slide. Take a second and please use the chat function, and you can either do it publicly as a question or directly to Gary. Are any of these resonating with you? Are you looking at implementing more of an IIoT or more of a tightly connected network to take advantage of one or more of those? This is just kind of for our own edification, and we like to understand where actual users are seeing the big benefit. If you have something that's not on the list, please feel free to add it. I'll give you a second there. Okay, thank you. So the traditional layers of a plant network consisted of some ERP and high-level enterprise class systems up top. And then as you went down a little bit further on, there might be some asset tracking, there might be a manufacturing system, there might be a little bit more coupling with actually producing what you need to produce. And then you get a little bit lower now where you're starting to get that merging between the actual plant and the enterprise side. That's doing your historian, maybe OPC, SCADA, doing a little bit more of control of actually what's making it. And then as you move down lower and lower, you have your PLC, which is generally just an endpoint that's connected via field bus to its end devices. So you'll see your motors, your drives, your pumps, valves, actuators, all sitting down there. They were all communicating in a very disparate manner. That is to say that they were all actually not well integrated. One of the goals of IIoT is to allow a couple different things. One is more of these devices to talk and to talk in an efficient manner, but also if they can't talk to the PLC, allowing them maybe to talk to the cloud. And there's one technology at the end that will talk a little bit about what that might look like. But it's all about, IIoT is about gathering this data at the bottom of the pyramid and breaking this pyramid into more of a peer-to-peer structure. And the animation isn't there. So breaking this hierarchical pyramid into more of a peer-to-peer relationship where everything can talk to everything else without necessarily going through a hierarchical pattern and without having to talk layer by layer by layer. Just a couple quick data points about where this information is coming or how it's actually flowing. Industrial Ethernet's growing somewhere around 22% a year. So it is now overtaken other protocols like field bus protocols, the serial type protocols. It is now not just the plurality, but actually the majority of communication on the network. You still see things like the ViceNet and CC-Link and Modbus in its RTU form, still holding on pretty well, but there is a trend, and the trend is to that Ethernet-based communication, which is why companies like Springfield and Phoenix Contact are so eager to keep driving the technology that enables this to happen a lot more seamlessly. So we have, hopefully this automation is coming through clear. We're just kind of showing some of the communication patterns on a factory floor. We're going to focus on all of these throughout the webinar series that Phoenix and Springfield are doing together. But today we're really going to focus mostly on the first two. A little bit about that wired communication on the production line itself and wireless access, how you can leverage some different wireless technologies to make your plant more effective in its communication. Down the road, we'll talk about network security, remote access, and even some different types of control. This next slide is something that we've been using at Phoenix Contact to try and explain a little bit in a linear fashion what IIoT looks like and how that connectivity happens. So what it does is it just breaks down on the right, the devices, the sensors, the things that are measuring and doing the actual control of your network. The middle being the Ethernet infrastructure that we're going to focus on a lot today. And then on the left, some of those cloud services and remote technology enablers. And then on the extreme left, the control, the visualization, the network security that's protecting everything. And then if you go all the way to the left, not pictured on this particular slide, would be your cloud. Something that's taking that big data, analyzing that data, chopping it, slicing, dicing, and feeding back to you the information that allows you to have more uptime, more optimized processes within your plant, and so on and so forth. So unfortunately, the talk today that I was lucky enough to get isn't really the sexiest. I think that's really the control side, the data services side that I just circled there with Profi Cloud that visualizes data, and the control platform that's doing a lot of the hard work with that data, transforming it, and so on and so forth. It's also really probably not the most practical or the ones that maybe can show an immediate return on investment. I think a lot of that is the remote access, where you're able to get support to a remote location, or if you're a machine builder, you're able to support a machine from far away. You don't have to put somebody on a plane. You don't have to deal with long downtime. You can actually just fix something over the internet. It's probably not even the most serious or earnest topic. I think that's cybersecurity, which today is the first day of Cybersecurity Awareness Month. But what we are talking about is the Ethernet infrastructure. So it's not the sexiest. It's not really the most earnest. It doesn't have the biggest immediate return on investment, but it is the biggest enabler. It allows devices that weren't able to talk before to get that communication that they need up to the plant. So when we talk a little bit about what IIoT needs from infrastructure, one of the topics that I always try and kind of hammer home is communication density. So what that basically means is, hey, there's a lot more things that are talking in a plant. It used to be your PLC would communicate via a network connection, but everything else might just be a single serial, giving a little bit of data here and there, probably not too much diagnostics, certainly nothing in terms of predictive maintenance, and certainly not enough information to be fed back to you in optimization from an optimization standpoint. But now we have all of those devices. Everything is becoming wired. Everything is becoming more intelligent. So what communication density is just allowing those things to talk. It's not, again, not really a sexy or not really a difficult concept to wrap your head around, but it does have practical considerations and it does have practical concerns, and we'll talk a little bit about that. So one of the first things that communication density means is just physical port density, right? Again, not sexy. It means that you used to use 5-port switches, then you used 8-port switches. Now maybe you're using 16-port switches. No big deal. It also means the availability or the usability of the wireless spectrum. So normally when we think of wireless, we're thinking Wi-Fi, 802.11, but increasingly it can mean things like Bluetooth or even next generation cellular. And I have a couple of slides on that we'll dive into, but that's another means for all of our devices to communicate. And And then the last part of that communication density bullet point is it's not necessarily putting it where you used to put it. You used to have to aggregate all of your information back in a central control cabinet that would have a trunk line or maybe a fiber backhaul or whatever higher up in that pyramid. So going from the PLC area in that control cabinet, maybe up to a SCADA system that was watching over 10, 15, 50 different control cabinets and recording that information in a historian, and then moving that higher up the chain, higher up the chain, higher up the chain. Well, now we don't really need the communication path to be so rigid and to follow that pyramid quite so tightly. So where you're aggregating your communication doesn't necessarily need to be the cabinet. It could be right on the machine. It could be wireless, where you have access points that are mounted outside of the cabinet, giving them the ability to communicate from otherwise stranded locations. So it's a pretty exciting topic. We'll touch on that with wireless and a little bit on the Ethernet infrastructure. The bottom half there, talking about density, I want to point out that communication density is not necessarily the same thing as throughput. One of my big challenges and one of my frustration points in my job is when people think that this is too expensive, or their idea of utilizing IIoT or digitalization or a smart factory, whatever you want to call it, is too costly. And it's because they're over-speccing what they need today and what they might need for the foreseeable future. So I like future-proofing. I like things that are gigabit capable, but I don't want to be Pollyannish about this. I don't want you especially to necessarily throw too many resources at a problem that your budget blows up and you have somebody not associated with the operation side of the business say, too expensive. This is triple what we thought it would cost. Where's my ROI? And over-speccing products can sometimes be a problem. You don't often hear a lot of marketing people talk about that, but I just want to point out that density is not the same as throughput. I see a lot of people doing a little bit too much there. So if you know your application, if you know where you are today, I highly recommend baselining what you're utilizing. I see a lot of customers who are actually using only 3, 4, 5 megabits per second, but they're still putting in gigabit switches. That's great, but it does have a cost detriment to that. If you're familiar with Wireshark, it's a fantastic tool. It'll show you what you're using. So even if you're using something Ethernet IP with a bunch of devices doing 50 millisecond or 100 millisecond polling, the data is so small, and 100 million bytes per second is, or 100 million bits per second is very large. So be careful there. Okay. So let's talk for just a little bit and set this up. At Phoenix, we tried to break the digital factory and what IIoT and digitalization might look like into a handful of topics. Some of those mirror that slide a little bit earlier that had all of the moving infrastructure around. So we look at data collection and storage, which is a true IIoT, all about the data. Where are you putting it? How are you moving it? Or where are you putting it? What are you doing with it? How are you slicing it up? Data security, data usage, and the infrastructure. We're going to focus on the infrastructure piece, specifically smart automation network and the connection of smart devices. We like to use the word smart a lot. What those use cases look like, and I want to talk a little bit about unmanaged versus managed switches. I think most people are familiar with the concept and the benefits and considerations of each. So sometimes we have slides that disappear. Other times we have slides that were hidden that maybe weren't so hidden. This is again just sort of showing a walkthrough of requirements, mapping them out to what an application looks like. And even though this slide I originally had hidden, I will make lemonade out of some lemons and point out that my previous comments about bandwidth are applicable to everything except when you start talking about cameras and cameras as a sensor. In that case, you really do need bandwidth. So the first bullet here of point 2, more bandwidth. When you're talking about cameras, bandwidth absolutely becomes a huge consideration and something that you need to future-proof because of their demands. The additional topology possibilities that the smart networks now give you and your IIoT applications might demand. Redundancy, for example, gives you resiliency. Resiliency is just another fancy way of saying uptime and keeping those things running. So we'll talk a little bit about managed switches and their ability to do that. And then here, yep. Okay. So a little bit about unmanaged versus managed. Again, I try not to be a snob on this topic because I realize that there are a lot of practical considerations and that a lot of people are sometimes pushed away by sometimes seeing technology shoved down their throat when it's not applicable. So let's talk about what's applicable and when. An unmanaged switch is basically an Ethernet terminal block. We talk about this all the time. They're not a sexy device, but they're a very effective device. They're a little bit dumb. They don't have management. They don't have an IP address, but they're super easy to set up, which means they don't require IT intervention. They have a very attractive price point where you're looking at maybe $15 or less per port. So it doesn't become prohibitively expensive to implement them. Their use cases are primarily way away from the core of the network. So distributed locations on the edge of a machine, on the edge of a factory floor network, where you don't necessarily need all of the benefits of managed, like redundancy or traffic filtering or shaping or things like that. So their use cases are simple, but their benefits are there. You're still able to collect data from devices. They're still acting as a conduit to that information, getting back from the hinterlands of your factory back to somewhere where that data can be used and manipulated. So that's unmanaged. We'll talk about a couple of things on that in just a second. Managed is what we typically think about when we're moving into higher level parts of the network. They have a lot of functions that unmanaged don't have. So they can do IGMP filtering and traffic shaping. They can do VLAN, which becomes very important when you're trying to segregate traffic or integrating into an IT network. They allow you to do redundancy, which we just said is key for resiliency and for uptime. So they're allowing you to build things in a ring or in a mesh network where you don't have some of the concerns about, oh, there's a cable break or a forklift runs over something, and now, oh my gosh, I just lost all of my production information. It simply reroutes itself to a different path. The downside of managed is, of course, cost. So you're looking at about triple the price per port. And the complexity that goes into it. So I don't really know exactly everyone's background on the call. If you're IT, you completely understand the benefits of managed switches and you would never dream of using anything else. If you're on the OT side of the house, or if you're an application engineer or controls engineer, you might understand, okay, I'm using a bunch of Rockwell devices. They're very chatty. They're using some multicast. I need managed switches to limit that traffic so that it doesn't start to overwhelm my network. They have their benefits, but they have that complexity. So you now need to know how to set them up, how to maintain them, how to use them properly. I have seen more than one use case or more than one application where VLANs caused a lot of problems with people who weren't familiar with how to use them. I want to take just a minute or two talking about a new unmanaged switch line. I did warn you there'd be a little bit of product mixed in here. And this is the new 1000 series switch. We just released it last month. It has the simplicity and the very attractive price point of unmanaged. It does have some unusual benefits for an unmanaged switch: application protocol prioritization, which is sort of a fast pass for industrial traffic, and slimness, 22.5 and 40 millimeters wide, and some flexible mounting. So it's great for those simple applications. Talking about application protocol prioritization, it actually allows higher priority queues for industrial protocols, Ethernet IP, Profinet, BACnet for building automation, Modbus, CC-Link, and so on and so forth. So what it looks like, and again, I'm hoping that the animation comes through okay, is that you have on a normal network this normal traffic and everything goes in, it's not too busy. I just said, hey, you know what, most networks are underutilized. So like this, you're fine. First in, first out, hey, nobody's in a rush. However, on higher density networks or networks where you might have a camera application, for example, or you're using cameras as sensors, all of a sudden that link all becomes a lot more full. And what you want to avoid is your automation protocols, in this case represented by the green and yellow of Profinet and Ethernet IP, being pushed to the back of the line by what we're calling standard traffic. So even though the gray packet goes into the switch first, the switch is smart enough to realize that, hey, this Profinet and Ethernet IP, this is automation traffic. I'm an automation-centric switch, so I'm going to move that to the front of my priority list. I'm going to bump that to the top of the buffer and get that out first. What that means is it's reducing the latency, it's reducing any jitter, and it's making sure that the most important packets that you have on your network get there on time. If anyone has any questions on this, usually we do a little bit of a deeper dive on how the switch does it, but it's a really cool feature, especially for unmanaged. So if you have any questions, it's going to become a thing that other vendors are implementing. We got to the top of the mountain first, though. And then one other point on the topic of these new unmanaged switches is their slimness and mounting flexibility. On the right, again, I mentioned 22.5 and 40 millimeters wide. So 22.5 for an 8-port switch, 40 millimeters wide for a 16-port switch. Those are both the thinnest in the industry. As we keep talking about more and more port density, that's all taking up DIN rail space or cabinet space. So the more ports you can jam into a smaller housing, the better. And then on the left, we have pictures of the switch being mounted in several different orientations. Comes with an optional bracket that you can order that allows you to put it on the DIN rail in any of the 90 degrees around or just straight on as normal. You can also do that on a panel, so you can machine mount them. So when I mentioned before, sometimes you have to think outside the box or outside the cabinet with where you want your devices to be able to communicate. This is an example of how you might be able to get that port density outside of the control cabinet and on your machines. Okay, so shifting gears a little bit to managed switches, no real hot takes here. So I can talk about all of these features individually. I don't want to belabor the point of things that everyone knows, but what managed switches give you and how that relates to the industrial network and the IIoT space is redundancies, VLANing, and IGMP filtering. So I mentioned all three of those at various points in the last couple of minutes, where redundancy makes sure that if you lose a link, the network reconfigures itself so that you don't have any downtime. You can still talk to all of your devices automatically. VLANs is simply a way to segregate traffic that's on the network. So some people use them for security. A lot of people use them for traffic management. IT use them all the time. So when you're interacting with IT or connecting directly to an IT network, if you don't have a VLAN, they really absolutely won't want to talk to you. And then IGMP filtering, just a way to filter multicast traffic that's very common with an Allen Bradley Rockwell control platform. They also have traffic prioritization, so they can do much of what the unmanaged switches are being built with natively, although there's a little bit more effort to get there. They also have diagnostics and some limited security. So I won't steal any of the thunder for security, which is coming up in a couple of weeks, except that it's incredibly important. Again, today is the beginning of Cybersecurity Awareness Month. So managed switches give you something there that unmanaged don't. And diagnostics and that ability to manage, to see what's going on your infrastructure devices is also very critical for IT, not only for the management, but also for the deployment and the upkeep. I have a slide or two on that in just a second. The hotter take here, or the thing that maybe is less known, is many managed switches, including Phoenix Contact, but not limited to, have implemented integration of different industrial networking platforms or industrial protocols into those switches. So having that native industrial protocol support means that you can do things like configure those managed switches, not from their web page or not from SNMP or some console, but actually programmatically. So you can go into your S7 program, or you can fire up RS Logics, and you can actually program attributes of the switch. Which ports are up, which ports are down, which ports are auto-negotiating, if you have redundancy on, whether it's DLR or rapid spanning tree, if you're using VLANs, all of those can now be integrated programmatically. And again, not to steal an upcoming presentation's thunder, but having a flexible control platform that gives you several different means and several different mechanisms to control not just your application, but your infrastructure is a very smart way to do things, and it is a very IIoT friendly way of doing things. So in addition to having the integrated or the native industrial protocol support, it does allow you to integrate the diagnostics, the health, the activity of your devices, of your infrastructure switches into your PLC control platform, which means that you'll be able to see what's happening and react to what's happening to your infrastructure in the program, and not have some operator get a red light showing up on an HMI and have to decide what they want to do, how they want to react. You can actually plan for different things happening within your infrastructure. The switch can report that information to your control platform, and now it's your PLC that's making intelligent decisions about if it wants to do something different in its application, whether that's shutting down a port, whether that's doing something programmatically like speeding up the line or slowing down the line. Maybe you're seeing your port utilization creep higher and higher to 90%. Rather than have dropped packets, maybe it makes more sense to slow down your production line or to spin down a line to allow that network to remain in a healthy state. And then last but not least on this smarter integration is faceplates for your HMI. In other words, you can now, regardless of your control platform, integrate the switch right into your HMI. So even though I just said you don't want an operator having to make snap decisions, well, that same operator can actually see what's going on in the infrastructure right in their HMI, written in their native HMI code. So that means configuration and metadata are all now available to the PLC, and ultimately able to be pushed up beyond the PLC, higher up into that stack, into the enterprise, and then into the cloud or an on-premise server that can have a more holistic view of what's going on. I mentioned Phoenix Contact has these. Again, we're not the only one who does, but kudos to us. We integrate the three key players, at least that we currently see in the North American market, into different switch lines. So for that Rockwell Ethernet IP centric platform, we have the 7000 series. For Profinet and the Profinet and Siemens, we have the 2000 series. And for Schneider and that Modbus TCP, we have the 3000 and 4000 series. This is the Modbus, I think, is a lot more infrastructure focused. It's not used quite as heavily on the factory floor, but I still wanted to put it here for the sake of completeness. Talking about central management as one of those enablers for IIoT and getting the most out of your network, this is something that's very important to me. I come from an IT background. Before coming to Phoenix Contact, I was the dreaded IT guy who had to deal with everything everyone was doing in a logistics center or on a plant floor. So I was really, really, really into central management. Despite what some people may believe, IT is generally stretched pretty thin. So they like to work smarter, not harder. When the OT side of the house, the control engineers, the plant managers, or the maintenance staff are deploying devices. It's kind of a necessary evil, but for IT, it's kind of their reason to be. It's their whole thing is keeping up that infrastructure. So the ability to do that efficiently and the ability to retouch those devices, whether it's for firmware upgrades or reconfiguring them, it's essential. So just like the OT side might be very excited to programmatically through these features affect the infrastructure and change things on the switches, IT doesn't work that way. They want to be able to do it via a central console or a central server that's able to read in all of this information, generally diagnostic firmware versions, utilization, things like that. And then if necessary, send those reconfigurations or those updates out. Again, some of the driving factors of this is the fact that this is how they grew up on managing equipment, and that they generally are more centralized and less distributed. There's always a plant manager, there's always some maintenance staff at every factory that you go into who can do things for the OT side of the house. On the IT side, that person generally doesn't exist. So asking them to touch 100 devices or 200 devices manually or one by one just is a non-starter for them. This, to me, the need for centralized management, to me, is probably the biggest driver for managed switches versus unmanaged switches, certainly from an IT side. I think there are some people who are on the call who may have had firsthand experience with what happens when IT decides that they want to have a more active role in speccing out equipment. And a lot of times it comes down to, is it compatible with my central management platform? Full disclosure, Phoenix Contact has an absolutely fantastic network management tool called FL Network Manager. It allows you to upgrade devices, push new firmware out, change configurations, visualize your topology, do backups, do restores, all sorts of good stuff. So we've got you covered there. Okay, I wanted to shift gears a little bit onto a new, I say new technology, it's really not a new technology, but it's one that's being leveraged more and more. Hopefully everyone here is starting to take advantage of it, but it's power over Ethernet. So I just have 3 or so slides giving some details about it and its place in the IIoT or the smart factory infrastructure. A little bit of a glossary here. When we talk about PoE, there are PDs, powered devices, which generally think of sensors, cameras, access points that are consuming the power that's coming over that mixed Ethernet line, and the power sourcing equipment, the PSE, which is generating the line. In our world, when we say PSE, we generally mean a PoE switch, a switch that is delivering not only the data connection, but the power connection as well via that Cat5 or Cat6 cable. When I said before it's kind of emerging, that's not a completely accurate statement. It's been around almost 20 years, but it's really being used more and more. The 8023 AT standard, which we call PoE Plus, is what really started to make it a little bit more applicable in the factory space. So once enterprise had adopted it and was using it for 5 or 6 or 7 years, you started to see more and more folks using it within the plant floor. The technology, the standards as they're emerging, they're allowing more power to be delivered. More power means you can start to run more and more devices or different kinds of devices on there. As I mentioned before, it's an enabling technology. So its place in the IIoT ecosystem is essentially it allows for more connectivity in more places, in different places. You're not spending the extra money to either run a separate power cable out there or have a separate power supply that's all the way out by your end devices. So you're able to power some of those end devices, those sensors, those cameras, those access points, those kiosks, even some smaller HMI and IPCs are now able to be PDs, powered devices via PoE. So that's a big part of IIoT. It's getting not just the data out there, but if you can do it in a more cost-effective manner, now when you're looking at a new application, you can get that sensor or get those edge devices connectivity by justifying it, saying, hey, we'd have to run a power connection out here anyway. Why don't we save that money? Just run an Ethernet connection out here. That'll provide not just the power for that device, but it will allow us to communicate with it, pull data from it, and let it be part of that IIoT infrastructure. And then the last big thing that PoE is enabling from an IIoT standpoint is camera as a sensor. If you haven't heard that term, it's one that I think is starting to become a little bit buzzier. Three primary use cases. One is safety. Camera is able to detect when an area that shouldn't be breached gets breached. So whether it's redundancy for a light curtain or whether it's going to places that traditional safety devices don't have a real good way of doing, it's perfect. Product validation. So again, smaller cameras have been used forever for doing product validations, reading things, making sure labels are on straight, and so on and so forth. Now, just more so and in a more cost-effective way. And then lastly, perimeter security. So whether that is doing surveillance or doing monitoring around a factory floor, outside a factory, a loading bay, an unloading bay, inventory cage, things like that, it's just allowing your vision to now be part of the sensor infrastructure. And please don't think that it's just some person sitting there looking at a screen, waiting to see somebody reach in and do something. Cameras more and more are now able to feed what we would consider industrial data, inputs, if you will, to PLCs, and those PLCs are able to recognize those, or those IO blocks are able to recognize, oh, the camera saw something that looked like a person. This area, this camera is monitoring a place where a person should not be. Therefore, I'm going to trigger a stop. In the industrial automation space, we see a couple, well, several use cases, but a couple that we'll just highlight: vision systems and sensors, wireless access points, and then those kiosks and IPCs, sensors everywhere, the cost savings and the ease of installation, and then allowing you to be more flexible and more scalable in your manufacturing space. We also see a lot in the ITS space, the intelligent transportation system. So if this is an application area that you're interested in, or that you have more responsibility for as opposed to factory automation, hit us up in the chat and we'll go there. If you would, please take a second before we switch slides here to put your thoughts in about PoE in the chat, again, just like we did before. If it's something that you are looking to do, or what your questions or challenges might be, again, it's a very quickly emerging technology that we're seeing. About 1 out of 3 switches are now globally being sold as PoE switches. So the infrastructure is getting smarter. The infrastructure is getting more cost effective by doing that. So if you take a second, I'd really appreciate it. While you're doing that, I know we got a little bit of a late start, so I want to be mindful of time. Let's talk a little bit more about the second half of the digital infrastructure set of use cases, which is the remote connection of smart devices. So with that, it's wireless technology. We're going to talk a little bit about why use wireless, some Wi-Fi versus Bluetooth, or make sure that everyone's familiar with those technologies, where they are, where they might be going. Just a bullet point on the emergence of 5G, or a slide or two at the very end as well. So wireless, from a very general standpoint, why are people using it? Very simply, it's a lot easier to use than running cables, right? As opposed to trenching cables or running conduit, or climbing up and trying to run things all over the place into dangerous locations or across dangerous locations, and having a patchwork, lattice work of cabling. Wireless removes all of that, and it does it in a very simple, very safe, and increasingly efficient manner. So when we look at Wi-Fi, which I'm using Wi-Fi as the trade term for 802.11, compared to Bluetooth, they're both IEEE standards. So neither of these are industry dominated standards. They both grew up as an IEEE standards. They both started as commercial technologies that have now migrated to more industrial technology. So that means they've been put in more ruggedized housing. They're using chips that are more rugged, wider temperature ranges, more resistance to humidity and noise. In some cases, it means that they are able to output more power, which means greater distances, greater throughput, and so on. On the WLAN side, or the wireless Ethernet side, there's more security built in. So this is generally part of the standard. So with different types of encryption and different types of security models, you're able to leverage that technology in a very safe and secure way. Again, I think that's something that Miriam might talk a little bit about in her presentation in a couple of weeks. It also tends to give you a bigger pipe. So the WLAN side, or the Wi-Fi side, continues to innovate, and they focus a lot of their innovation on bandwidth. So back to that question of how much bandwidth do you really need? If the answer to that question is a lot, maybe you are doing wireless video, something like that, great, Wi-Fi is the way to go. But if not, Bluetooth is a very attractive option, and it's something that we see more and more in industrial automation. It's simpler to set up, simpler to connect. There's a little bit less latency than what you typically would see in a Wi-Fi application. And very important in my eyes is on the right, there's a very unhappy emoji, and on the left, a very happy emoji. That represents IT. Again, none of our factories exist in a vacuum. None of our production sites are devoid of IT's influence. So generally, IT has a very skeptical, if not outright oppositional standpoint to WLAN, to the 802.11 space, because that's their space. They're running all of their enterprise information over 802.11 networks generally. Whereas Bluetooth, even though it's using that same 2.4 gigahertz space, it uses a different technology to access that spectrum. It doesn't bother them as much. So Bluetooth, even industrial Bluetooth, is generally much more accepted by IT folks. A little bit here about the 802.11 wireless standards. I won't go too deep into it, but right now 802.11n and AC are both standards that we currently see. The ABG stuff really more or less has been put out to pasture, certainly for new applications. The two things that I wanted to highlight, just so that you guys have a data point, is again that throughput number, 600 meg versus 1 gig, and the typical range indoors of 200, 225 versus 90 foot. So 802.11 AC, you are getting more bandwidth, but the cost of that bandwidth is the need for a higher density of that connectivity of those devices to their access point. Also, 802.11n can work at both the 2.4 and the 5 gigahertz spectrum. I like the flexibility of using both, whereas AC is something that is limited to the 5 gigahertz space. There is Wi-Fi 6. So if we count 1, 2, 3, 4, 5, next in line is Wi-Fi 6. That's 802.11ax. I think I have a slide or two that may be hidden on that. Again, my apologies. When I came back up, some slides that I thought were hidden were not, and some that I hoped were not are. But if you have any questions on the AX side, we can discuss those after the fact. From a wireless standpoint, some use case, again, efficiency in operation, the ability to put something somewhere and not have to rerun wires. This is particularly important in a brownfield application. Greenfield means something new where you're building it from the ground up. Brownfield means this is something that is being overlaid onto an existing location or an existing infrastructure. It's really freaking expensive to do some trenching or some conduit running if you're in an existing production factory, right? It means downtime. It means you're locking out certain machines while you get up and run the conduit around. It can be really expensive. Wireless gets you past that problem. It allows you to get the information that you want in a very quick and costly or cost-effective way. It also allows your operators the ability to pull some information right off of the machine. So we're seeing more and more mobile type applications where operators are using iPads or other tablets to interact with their machines. In fact, we're also seeing some pretty exciting use cases, and I don't really have a lot of good collateral, and I didn't want to put it because it's a little too forward looking, but things like smart wearables and Google Glass, for example, interacting with machines using Bluetooth or Wi-Fi. So again, it's something where, hey, 5 or 10 years ago when that line was built, they didn't need wireless there. They probably didn't even need network connectivity, period, if it was 10 years ago. Now, with the emergence of these new technologies, they have the ability to slap on a wireless product, like the one shown here on the right, the 1100 series, and get connectivity, whether it's near connectivity for an operator or whether it's connectivity to the enterprise. It allows them to do things that they simply couldn't do before. And then another big use case that we see is with AGVs, automated guided vehicles. These are all over the production floor now. They make the moving of materials, whether it's material to be produced, the raw materials, or the finished goods, or things in a pick and pack. It's making it so much easier for them to use. You're able to implement efficiently a wireless network on these devices so that they can not just be semi-autonomous, but pretty much completely autonomous, where they're able to have a wireless device acting as a client mounted right on them. So one of the devices here, the left foremost, on the device itself, as it's roaming around the factory, it's still able to communicate with that wireless infrastructure wherever it is. You may say, well, wasn't there a limitation of a couple hundred feet? So what if it's a big factory? It's not a problem, because one of the benefits of 802.11 being so mature is that the standard allows for roaming, it allows for communication, even as the device is moving all over that factory floor. So AGVs are something that we're seeing kind of an explosion in, and companies like Amazon are already using this technology, our technology, to make it work. So in the interest of time, I won't go through all of these, but it's sort of taking an autonomous forklift and showing all of the different smart devices that can go on there, not just infrastructure, but things like smart batteries and smart power supplies, putting the control and the HMI on there. So Gary's going to be sharing this presentation in the next couple of days, so you can take a look at that. And again, that's just another representation of the devices that are able to roam from access point to access point and still keep their communication up seamlessly and without interruption. Wi-Fi 6 was not included on that previous graph, but I did want to put kind of a little bullet point or two in your head. It is something that is being talked about a lot. And I won't get into all the security pieces here, but it's being talked about in the context of, is this really the next thing for factory floor wireless? Well, what would the alternative be, you may ask? Surprisingly, the alternative might just be 5G. So I know 4G is just here and we're talking about 5G, and there's already meetings about 6G, but 5G is the new big thing, right? It's being rolled out to big cities already from a consumer standpoint. But there's also a lot of talk about its ability to support very dense applications like a factory floor with very low latency, very high throughput, and very good security that might make it a competitor to the de facto wireless communication to the next generation wireless Wi-Fi in the next couple of years. So this is going to be ultimately Dave's topic. Dave Hoysen next week is talking remote connectivity, which will include cellular. So he will be highlighting these topics a lot more. But I did just want to point out that it does have a few big things like the ultra reliable low latency communication, URLLC. I'm not making that up. That's how they're referring to it. Enhanced mobile broadband, which is giving you super high throughput. So 20 gigabits at less than 10 milliseconds latency, and huge density of million devices per square kilometer. So what does that mean in a typical factory, which is in some cases smaller than a square kilometer? It means that all of the devices that you could possibly want in your IIoT application might be able to use 5G. They're still talking about the cost and the applicability and the spectrum. But another little piece of homework for you is, have you heard of 5G on the factory floor before? Is it something that your company is talking about, looking at, doing a little bit more investigation on? And what your thoughts might be on that. I swear to you, any of these chats that you give us will not be used to spam you with unending marketing material. It truly is for our own edification and to make sure that we as a company keep our finger on the pulse of our customers and of the users of that technology. So again, 5G, it can be used a lot of different places within the factory. Everywhere that you might be thinking that traditional wireless is used today. So food for thought on that, and I believe Dave will have a word or two on it in the upcoming session next week. The last topic that I really wanted to talk about is, again, an emerging technology, an emerging topic, and it's called single pair Ethernet. This is something that Phoenix Contact is into. We're into on the connector side and on the cable side, and we'll soon be into it on the infrastructure side. So again, it's something that's maybe not quite at the peak, certainly not the peak of the adoption curve, but just entering that higher awareness level where people are starting to talk about it, hear about it, read about it in control engineering or automation world. So I just wanted to spend a slide or two giving sort of the value propositions, why it's useful, and again, its place in plant level communication and IIoT. So it's big drivers why it was so important, or why it was deemed as necessary, is with the tremendous proliferation of end devices, cabling can sometimes be a higher cost. So there's a cost consideration of running a Cat6 cable to a sensor that really might not need all of that. Sometimes Cat5e, Cat6, there's a little bit of waste in that cabling where you have 4 pairs of cable and maybe not all of them are needed, right? Especially if they're not using PoE. So there's the cost and the fact that we have all of these devices, and some of these sensors are very, very small. So you're looking at things where the real estate on the sensor might not be amenable to an RJ45 connector. Single pair Ethernet, because it uses less real estate, is something that is a driving technology there. But then it's also able to actually fulfill the need for high throughput at remote sensors in an application. So the bottom right has a little purple box. So you're getting standard Ethernet functions, right? Nothing different. You're still communicating Ethernet and TCP/IP and all that good stuff, but you're doing it at data rates up to a gigabit. Now, not everything will have a gigabit, but up to a gigabit, and range of up to 1,000 meters. So pretty exciting stuff that's emerging. There are a couple of competing standards. So I think things are going to shake out in the next 18 months or so, but it's something to put on your radar. And its goal is to help, again, shake up that hierarchical pyramid that we talked about kind of at the beginning, and allow sensors to communicate directly to either the cloud or the control network without having to go through some of the other layers. It's sort of a democratization of the plant floor, and it's allowing sensors that previously were only communicating via field bus, whether that field bus was something like CAN in the automotive space, or a Modbus RTU, or a device net or something like that, allowing them to use standard Ethernet and allowing the Ethernet revolution to sort of continue by getting those remote sensors on that same platform. Again, the industry trend that SPE is trying to take advantage of is more and more smarter devices, getting that vertical integration of those devices onto your network, and allowing those sensors to communicate real time, securely from point A to point B. So just like the Wi-Fi 6 and 5G, this is more of a forward-looking topic, I'm anxious to hear if anybody is on that adoption curve already, starting to talk about it, and where you're seeing it. This is something that next year will be all over the place, and everyone will be talking about how your plant is now more efficiently communicating because the sensors at the very edge of the network are able to be powered and communicate with SPE if they can get the cost down right. So with that, I just wanted to summarize a few final thoughts. IIoT and digitalization, the smart factory, whatever you'd like to call it, they are megatrends. They're not going away, but they're worthwhile megatrends. They offer a ton of value if you're smart enough to leverage them. So the predictive maintenance, the optimization, the ability to improve your process, to be notified, to be alerted when things are going wrong. You can really make your factory truly smarter, and the infrastructure is a big piece of that. Proven technologies like traditional Ethernet switches and traditional Wi-Fi absolutely have a place. There are emerging technologies coming. There might be some changes. There will be some realignment of what technology fits where. Not all of that is really shaken out yet, and it might be a year or more before that happens. So keep your eyes on the space because there's more to come. And then always, help is available. Your friends at Springfield, your friends at Phoenix Contact, we do try and live and breathe this stuff every day. We understand that technology moves very fast. You can't be an expert on everything. So we're here to help. And with that, I want to say thank you for your time. I appreciate you sticking with us, even though we went a little bit long. And I want to once again thank Gary for hosting. I think he's going to take some questions, and Springfield for sponsoring these seminars. So October 8th will be our next one. But before we talk about the future, let's talk about the present. Gary, are you out there?
I am. Thank you very much, Dan. Appreciate
Disembodied
that.
voice.
Yeah, thank you very much. Appreciate that. Great information. We will open for any questions if anybody has any that they'd like to ask. If not, if you'd rather do it offline, we can certainly do that. Or if you're short on time and you need to move on, we certainly understand that. We can take these questions at a later time if you so choose. Do we have any questions? And you can unmute yourself to ask. Okay. Well,
I'm going to assume that was the most thorough presentation and that there were no possible questions that could have been asked.
Right. Hearing none, we'll go ahead and close it out. So Springfield Electric, in partnership with Phoenix Contact, can assist you in these solutions, including the specification, design, and implementation. In closing, we appreciate you joining us this afternoon. Sorry about the technical difficulties there at the beginning. We will have this as a recorded session. We'll follow up with an email of what you saw today and also a short survey. Your feedback is very important to us. Next week, Thursday, October 8th at 1 p.m. Central Time, we will host our second session in this webinar series, Prevent Downtime with Secure Remote Access. Please register for and join us next week. I'll see you there. Goodbye, everybody.
Thanks, everybody.